Right, let's get started with this question. Okay, we have a man who's going to start walking from a point, and we call this point X in the question. And he's going to walk on a bearing of 30. So let's set this up. This is north, east, south, and west. He starts at point X, and he heads towards in a direction that is 30 degrees from the north. Okay, and he travels, or he walks, a total distance of 4 kilometers. Once he reaches 4 kilometers, he turns and starts heading west until he is at the point directly north from the point he started from, which is point X. Okay, should we call this distance A? Because that's what the question is asking for us to figure out. How far did he travel west? So if I can extract this or move this triangle just down here for us to see, we have 30 degrees. This is 90 because west, north, they're perpendicular to each other, and we know this side is 4 kilometers. Shall I just rotate this triangle around so that it looks familiar to us? Okay, I'm going to do this first. We have theta. The longest side is h. This particular side that we are interested in is opposite to theta, so it's the opposite side. So that's how it works. We're going to first try and use the SOHCAHTOA rule. Okay, so we have 4 kilometers, and we also know this angle is 30 degrees. We want to know A, which is O. So we know, let's write it down, SOHCAHTOA. Okay, SOHCAHTOA. We've got all the degrees, 30 degrees, and we've got O and H, so we should be using OH. Let's use this. So sine 30 degrees equals O over H. Okay, we know O equals A, and we know that H equals 4 kilometers. So let's rearrange this, or rewrite this, sorry. We have A over 4 kilometers. Okay, from what we have covered, what is sine 30? Sine 30 is 1 over 2. So 1 over 2 is A over 4. So what's the distance of A? A is 2 kilometers. Okay, if you were unsure why A is 4 kilometers, which is perfectly fine because, our algebra tends to get quite rusty at times, so we can have a private chat about it. But if not, that's what it is. So we know that A is 2 kilometers. So that's our answer. But I'm just going to talk about a second way to answer this question. Okay? So we have, I'll draw my triangle again. This is a bit messy. Okay, I have a triangle 30 degrees, and this length is 4, and this is right angled, so we know that this is 60 degrees because the internal angles of a triangle must add up to be 180 degrees. Okay, so this is 60 degrees, so now we have this 30, 60, 90 triangle that we were talking about. But what we learnt today is if we have a 30, 60, 90 triangle, it's going to measure 1, 2, root 3, right? But this side is 4. So this side is, the original triangle that we were talking about has the longest side 2, whereas this bigger triangle has the longest side 4. So what I'm going to try and do is fit this triangle in this bigger triangle, which might just roughly look like this, with the 30 degrees, 90, still 60 degrees triangle, but this time it's a 2, right? We know that if this is 2, this is 1, this is root 3. Okay, and these two are similar triangles. So let's compare the longer side, 2 to 4 ratio. That's the ratio of our similar triangles. And we are looking for A. So we can just say this is 1 to A, right? 1 to A. You know, when we do ratios, the inner parts multiplied together and the outer parts multiplied together, giving us 4 equals 2A. So we can just say A equals 2 again. So these are two ways. Well, of course, the SOHCAHTOA rule is the best and it's the most commonly used rule. But you know, it depends on what kind of a day you're having. Sometimes this might not come to you, especially when you're in an exam. That's why I want to just show you how to use the 30, 60, 90 triangle rule. Okay?